Hi guys, I hope you're doing absolutely amazing so far. Welcome to this video where we will talk about the state management and data flow. So when we talk about the state management of a view, we know we use add state keyword to make property and the view watch over onto this property for any change. If there is any change, it will refresh the whole view. We will talk about how a view can observe class as well. So we'll talk about observable objects and let's get started. So here I've mentioned the add state that we have seen in a couple of videos. We'll talk about add binding as well. This is something used for when you want to pass on the add state property to another view. And we will talk about observable objects. That is when we have some sort of publisher inside a class and we want our view to watch over that class for any change. Essentially, watching over basically means watching over the change in the add publish properties. We'll take a look at this with the help of examples step by step and we'll understand. And when we want our view to watch over the observable objects, we will talk about the usage of add observed object and add state object. We'll go a step deeper into understanding the difference as well. Just like the previous videos, we have our view here, which is what we are previewing. And in here, we will run our examples. So let's get started with the very first one, understanding the add state. So state example is where we have the add state property. It's very straightforward. Just like how it was in previous videos, there is nothing more. It's just we have one add state property and it will maintain the state of the view. If there is any change in it, the whole view will get reinitialized. And in the body, we have vStack, and the vertical stack has two components, text and button. We click on our button to increase the count by 1, and then the text is going to reflect it. As soon as you click on the increase button, it is going to make a change in our state, and due to the change in the state, it will refresh the whole view looking for where the count is utilized, and it will update the value. And I have mentioned a short note here. It is used for simple state management within a single view. The view owns and manages the state. The best for primitive types like integer, string, boolean, CG, float, and some other built-in types like angle. And that is it. What we should expect from our simple example is the add state to SwiftUI to rebuild the view when the count changes or when the state of the view changes. We can use it when the state is local to the view and does not need to be shared. And now let's talk about what if I want to pass this count, the state property, to some another view. That is when bindings comes into the picture. So here we have add binding and we have one view and another view. The first view has the add state property is on and we just want to pass that add state property to toggle view. What we have to do is to create the add binding property and we are just going to pass our add state whenever we are going to call this subview. And that is how simple it is. Now let's take a deeper look into what the code is doing. So we have the toggle view where we have toggle component and we with the title switch, and it requires add state property so that, and it should be of type boolean. So whenever there is any change in the toggle, when you switch it on, switch it off, it's just going to change the value of that boolean. We want this add state property for that. So since it's completely separate view, we will have to pass this when we are going to call our view. So let's understand the code of binding example view. We have vertical stack and we are just calling the toggle view, and when we call, we just to our binding variable, we are just going to pass our add state property. That is how simple it is. Now whenever there is any change in the toggle due to toggle, is there in the add binding variable is on, it's basically getting the value passed to that state property. Since this property is now binded to the state property. And if you would like to imagine, this is basically just doing the work of giving the reference of the add state property to our subview. Now let's look at one more thing, but before that I will load this view so that we can see this in preview. So we have our toggle view, which is with the title switch, our toggle. Whenever we will switch it on, the text will actually reflect the change. So the moment you switch it on, you are making a change in the state property, which is this one. As soon as there is any change in it, it will refresh the whole view and look for where is on is utilized. So the text is using it, and if there is any change in the value, based on that, it will run the ternary operator and it will showcase the relevant text. And when we talk about passing, we know we have that state property. It has two versions. One is the simple variable stored property it is, and the second version is it's a publisher. When you add state, it's going to make the property a publisher. That basically means that whenever there is any value change, it is going to publish that value, and that means wherever it is used, it is just going to get updated like here. And that is it. When we have these two versions, which version do we use when we pass the add state to our subview? Well, we use the second version because we want to pass the add state publisher version of the property and not the simple property. Like if we use without dollar, it's a simple property. But our toggle has the add binding. That basically means we are expecting, or the toggle view is expecting the second version of the property, which is the publisher version of the property. And that is it. That's why we use the dollar sign here. And as soon as we have passed our state property here, we can utilize it in the toggle view anywhere. And we are using it here for the toggle. It will make a change in here, and that change is binded to our state property, so it will reflect it here. Hence, it will refresh the whole view. If it is utilized somewhere else in the text here, let's say, and I'm going to just copy this. Now we have the switch is off, which is basically this text, and our text right below the toggle is the value. So when you turn it on, it will basically update the value of this binding variable, refresh the whole view, and since our binding variable is binding to the state property here, it will reflect the change in its value, and that will make the view reload or re-render or refresh. And that is it. So I've mentioned a quick note here. Binding is basically passed. It passes a reference to the parent's view's state to the child view. The child can modify the parent's state without owning it. And when I use the word owning, we will understand it quite clearly in the upcoming example because it has a concept that we need to understand, because owning and not owning two different things. And when we talk about at state object and at observed object, we will talk about it. What should we expect from the example is what I have mentioned here. Parent view owns is on using add state. Toggle view modifies is on vi add binding. So when to use, the child needs to modify the state owned by a parent. That is where we decide to pass that state property to our subview or child view. That is it. Now let's talk about observable objects. So we have an example here. So we have a simple class here, counter model, and we have add publish property. So we have talked about add publish property in the combined course, and we talked about the observable object as well. But we are going to take a quick revision on it. And add publish is just used to make the property, give it one more version. So the first version, if we don't use it, it's a simple property. But when we use it, now the count has a one more version, that is the publisher version. That basically means that if there is any change in the value, it's going to publish that to its subscriber, and whoever who is watching over this add publish property. Now our view is not subscribing but actually going to watch over this add publish property. Before we jump into that, whenever we use add publish property or add publish to make the property a publisher, in the class we have to mark it as observable object because we want this property to be observed by the view. And how do we observe it in the view? We create the object of it. So we want to actually observe the object, and that essentially means we want to observe the object by observing all of its add publish properties. If there is any change in any of the add publish properties, the view will get to know about it, and the view will constantly will watch over this object. And when I say watch over the object, that basically means all this add publish properties, if there is any change in it, the view will get to know about it. So if we are using add published, we have to use observable object, and whenever we create the object in the view, we will have to take care of two things here. So we have created the variable counter here, and we are using add state object. Here, when you want to create the object of the class, we have to use, or we should use, add state object. If you want only the property with the type, you are not initializing, you basically means the view is not initializing it, then we should use observed object, because there is a difference between add state and add state object and add observed object. And the difference is, when we basically going to use it, we have to keep this one understanding in mind. Why is that? We'll understand that in a second. But just to get over it, whenever we talk about creating the property with the type not having any value, not initialized right now, it will be initialized when you are calling this view inside some other view. We will pass the object or the instance as the argument to this property. And we use add observed object all the time whenever it's going to get the instance from some other view whenever it is going to be called. Now we use add state object whenever we want to create the object. And when you create the object, the view actually owns the object. But when you are going to just create a property, the object is going to be passed from the parent view or wherever it's going to be called. So in case of observed object, the view doesn't own that object. It is owned by the parent, and the parent is going to pass to the property as an argument. But when it comes to add state object, the view owns the object or the instance of the counter model. Now what does it mean? Whenever the view owns the object, if there is any change in the view's state and the view is going to get refreshed, the view already owns the object and it does not reinitialize it. But when it comes to observed object, it will reinitialize it. And that is the difference. Now, why should we use or when should we use at state object is when we know that the recreation, to be specific, reinitialization whenever the view will refresh, that is not necessary for our view because we want it to persist once it is created by us. We own it, the view owns it, and should persist. Then we should use add state object, and that is the main difference. Now let's talk about our view. Here we have a vertical stack, a text, and a button. We are increasing the count here, counter.count, which is the publisher property. And here in the text, we are just reflecting its value. Let's load our observable object example. And we have this increase button, which will increase the count of the published property as soon as it is done. Our state object is observing the object or the instance, and it will refresh the whole view, but it will not create the new instance. And that is it. It will reflect in the view. So step by step, if we take a look, when I click on the button, it will increase the count. And as soon as there is any change in the add published property of the class, it is an observable object. So whenever you are utilizing it in the view is going to watch over the change in the class, or essentially going to watch over any of the add published properties if there is any change in it. And it's if it's there, then our state object basically going to refresh the whole view, and it is going to look for the add published property wherever it is used or accessed, and it will update the value. Now, since we are increasing the value and the view is getting refreshed every time, our counter model instance is staying the same. The one you created the very first time is the one which persists for all the refreshes. And this is just instance which is lying in a memory space, and the memory has an address. And when it comes to you using observable object, you have to essentially first pass to it. And if there is any refresh, then the object that you have passed to it from the parent view, whenever you will call it, that is going to get reinitialized. And we will see this in the next example. I'm just going to comment this. And that is all about add state object. And add observed object, I have written some notes here. So add publish ensures count triggers UI updates, and add observed object tells SwiftUI to watch counter model for changes. Both the properties has one similar thing. It's just going to observe the object change. And the only usage difference is when we are going to create the object and the view is going to own it. View owns it because we are creating it, but here we are not creating any object. We have just a property. It is going to be assigned a instance whenever the object is called or whenever the view is called. And when to use it, the state is shared between views but owned elsewhere. So in this case, the nodes are basically for add observed object, and whenever there is a view passing that instance to it, the parent view owns that object. And when we say owns, the parent view is basically creating the object. We'll understand observe object with one more example and get more clarity on it. And we have one problem with add observe object, and we have one problem with that observe object if the counter view recreates the counter. When re-rendering, the data will reset, and that is one of the feature of add observe object. It's not really problem, but it is the difference that we have to keep in mind. That is what makes the usage of add state object and add observe object different. Now that we understand theoretically what is the difference between add state object and add observe object, essentially, just to brief, if there is a view refresh, the add state object will not get reinitialized. The object that you have created, the view owns it and it will persist. When it comes to add observe object, it will get reinitialized. So let's talk about this one example here, which is regarding add state object. Just a quick uh, demo. We have the creation of the counter model, which is right here. And we are just mentioning the counter. This is basically the example for nodes I've kept here. And here it's exactly same. So we'll keep this for nodes. It ensures the observed object is only created once and persists across re-renders or reloading or refresh. So observed object is our counter model. It prevents the resetting state when a view is reinitialized by SwiftUI. So whenever the refresh happens, it is going to reinitialize, not recreate, but it will get reinitialized. There is a difference when recreation happens. The new instance of the whole view gets created and the old one will be getting discarded or destroyed. But when it comes to reinitialization, the same instance is going to get just reinitialized in the memory. And here I've mentioned some difference. When we talk about observed object, who owns the object? The parent will own the object. The parent will create the object, use the add state object keyword, and the parent we will own it, and it will pass it as an argument to the subview, which is using the add observed object. So parents owns it, and when it comes to when is it created, every re-render it will get reinitialized. And to be specific, it should be reinitialized. What is the observed object best for? It is best for passing down objects. And when it comes to add state object, view itself owns it. Only one refresh per view happens. So the reinitialization is going to be initialized only once, and the state object is best for persisting the state within the view. Use the state object in the view that creates the object, and add observe object in the view that receives the object from a parent. And now we will dive a little bit deeper into the add observe object and add state object. We have our counter model 1. I've changed the name so that we don't get the redeclaration error. We have the same counter property, published property. And here we have two views. One is the parent view and the child view. So parent view is going to create the object and going to own it. Since it is creating the object, it is going to own the object, and it is not really receiving the object as an argument. It's going to just create it. So we have to use the add state object here. And when it comes to the child view, we are going to call the child view inside our parent view and pass this counter, the instance, to our property here. So since this is going to take an argument, we have to use add ObservableObject. Preview this. Parent view 2. So we have our parent view count, which is our text, and a button, which is the increase button. And we have, let me add some spacer. So it will push against the edges. We have our child view after that, which is right here, showcasing the value of the counter of our counter model, and we have the button to increment it. And whenever there is any change in the parent view, it's not going to reinitialize the object here or initialize our variable with a new instance. But whenever there is any change or the view is getting refreshed, it will get reinitialized. And there is no way to demonstrate or write a separate code and give a demo because this is something that happens at the runtime. I tried multiple times to simulate the manual refresh of the parent view and manual refresh of the child view so that we can see the difference, that the state object is not going to create a new instance, but when it comes to observed object, it is going to create a new instance and destroy the old one. So it is practically not possible to manually refresh because when we do the manual refreshing in this code, I have one parent wrapper view, the name of it, and state property, which is based on which we are going to recreate or try to reinitialize our parent view so that we can actually see whether the state object is getting reinitialized or not. It should not get reinitialized. But what happens is this is going to create one new instance. It is going to destroy the whole view and it is going to create a new view. When the whole view is destroyed, it is going to destroy our counter model 1 object as well, which was persisting in the object of the view. So it's not really going to reinitialize it, rather it is going to recreate it. Imagine we have a memory location in the disk where instance of this view is residing, and now we are trying to reinitialize it. But when we actually try to reinitialize, it is actually getting it is actually creating the new instance. So it's going to destroy this one and it is going to create a new instance at some other memory location. And when this view destroyed the existing object, all of the instance, this instance, which was persisting, is also destroyed. So we will take a look at this once again, but right now we can see the usage of add observed object whenever we are expecting the instance in the argument. Whenever the child view is called, we should use add observed object. And when we talk about add state object, whenever you are going to create the object and the view is going to own it, that's when we use add state object. So when I click on the parent view increase button, it will just reloading. Maybe I'll refresh it. Let's click increase count. It's going to increase this and this as well. Let me remove the spacer. So we have our increase by the parent view, and the child view is also going to reflect that. If there is increment done by child view, it will update the parent view as well. And that is why we are having the parent view owning the object, and this one is just observing the change. And if we had used state object here, we will have to assign, it will not give you any problematic at the compile time, any problematic error or any indication that we shall not use it because you have not initialized it. But this is more of a runtime thing, so we have to keep this concept in understanding that we should always use the observed object for the, so if you use the add state object, it will still work, but it, and also it will not give any sort of indication it's still loading. So let's wait and let's click. It will still work completely fine. The difference is the moment you have used add state object, the object create, if you are going to create the object here, that is going to persist, but the object that you have passed, that object is going to be not refreshing when you use state object for the property which is expecting the value in the argument. So the only best practice is we should use add state object whenever there is a parent view where we are creating the object is the parent view. Whenever we have the property which is going to accept, that's where we have to use the property with add observed object. And this is going to observe the parents object. Let's try to force the refreshing, and we will then change it from state to observed object, and we will analyze both, whether when we are refreshing manually or forcing, is this getting reinitialized. And that is practically not possible, but I gave it a try to show you that practically writing a separate code will not help. It is a runtime thing and it will happen at runtime. So the best we can do is we can try to create a new view, and when we run it, let's try running. So we will take this, we will put this inside a structure along with the parent view, and we have the force reinitialization parent view v2. What we will do is we'll see if it's getting reinitialized, and after that we will see another case where we will change it to add observed object, and we'll understand whether that is getting reinitialized or not whenever the view is getting refreshed. So we are simulating the refresh with the help of this force initialization parent view to, but so I will increase it, and since we're using add state object, this should not get reinitialized and the values should stay same. When we will use observed object, this will get reinitialized, and the initial value in the counter model 1 is, this will set to 0. This is the expected. So let's run our first case that it at state object. So the value that we have 4 will should persist. So let's click, but it is refreshing it. The reason behind that is when we refresh, we are not able to really reinitialize, but rather recreate. So this is a new instance happening rather than reinitialization. And that is the closest we can come to imagine how the refreshing happens, but we cannot really actually see it by writing. It's a runtime thing. The SwiftUI takes the same instance, it's going to reinitialize instance, but it does not reinitialize this one while doing it. When what we are doing is we are going to just destroy the whole view instance here, and we are going to create a new one. We just go by one conclusion that we use add state object whenever you are going to create the object, and the view is going to own it. Since you are owning it, it is not going to get reinitialized whenever the view is refreshing. If you use at ObservableObject, you have to use it in the child view, where what we are generally expecting is the child view will actually gain the instance as an argument, and that's why we should use at ObservableObject, because the view, whenever it is getting reinitialized, it is going to reinitialize the object as well. And that is it. I have mentioned some note. I will correct this one. And in the notes I've mentioned why is add state still getting reinitialized, or I would say, so it's not getting reinitialized, it is actually getting recreated by our parent wrapper view. And to understand it better, to understand our example better, I have given a note here. So the state object is tied to the view instance. So when we are writing here the state object, it is tied to the view here, and the view instance is what is. So state object shows that the observable object, our counter model one, instance persists only for lifetime of that view. However, when the entire view, the parent view 2, is removed and re-added, which is what happening when we are running it. So it's recreation and a reinitialization. Recreation is you are removing it from the memory and re-adding it. The SwiftUI destroys and recreates the view instance. Since view instance, the add state object is tied to the view instance, that is also getting destroyed. And hence it's not a reinitialization how the SwiftUI does behind the scene. It's really the recreation we are doing. Since parent view 2 itself is recreated, its state object is also reset. The state object only persists if the view stays in the memory. The add state object only ensures persistence if the view remains alive, but the parent wrapper view toggles between two new instances of parent view 2, effectively discarding the previous instance. So we can increase the count, toggle it. It's just going to recreate the whole view, and the state property is tied to the view. The view is destroyed, so the instance is destroyed. So there is no manual way to see it. What we were trying to look at is I will refresh it manually and see the state object when used. It's not going to get reinitialized. If we are using observed object, it's going to get here, it's going to get reinitialized. Or here itself, we will make a change and see. So we will have to rely on our understanding and rely on the conclusion, that is, whenever there is a parent view, use a state object and it will own it. Whenever there is a child view and it's going to expect a value from the parent view, the instance, then we use add observableObject. Now let's talk about the environment object. So this is something like a global variable. You want to store your object in a global environment, and any view, any other part of the application can access it. It's something that is used for theme authentication, the user settings or application setting. At global level, we can keep the authentication status of the user, whether he's logged in or not, and we can give access to it to the different parts of the application. So I mentioned a quick note, passes share data through the Swift hierarchy without manual binding. And since global variable can be accessed from anywhere, we don't really need some sort of binding here. And that is what I've mentioned here. Useful for global app state like theme, something that we want to keep at global level and give access to the subpart of the system. For example, user settings. So we have the user setting and the username in it, and we have the structure here, content view, and profile view is our subsystem, some other part of the system who needs access to the user setting. So in here, we are creating user setting, a state object. It's going to own it. And we have a navigation view. I will actually load this first so we can see it in preview as well. While it's loading, let's see, we have a vertical stack, a text where we are just mentioning the name, and we are saying a navigation link to go to profile. Now for the whole navigation view, we are using this modifier.environment object, and we are just assigning our state object in the environment. So it's like setting the value or storing the settings object in the global variable or in the environment, which is accessible by the subpart of the system. Now we have the subpart of the system profile view. How do we access that settings? We have to create a variable, and the type should be user settings, and we have to use the keyword at environment object, and this will give access to our object settings. And we have a vertical stack here, a text and button. In the text, we are accessing the name, and that's it. When I click on the button, it will change the name as well. So let's run it. We'll go to the profile. Now when I will click on change name button, this is going to update our username, which is in our observable object, which is observed by our user setting view. And when this is changed, the add published property is changed inside the settings. The environment object setting is also changed, and all the subpart of the system like profile view who is accessing that object is also going to have that change reflected. And here we are going to see it reflected. So let's change it, and it is changed to John. And that is it. I have mentioned a quick note here. You need a global shared data accessible across multiple views without passing it explicitly. Then we go with the environment object. Some pitfalls: if a view expects an environment object but the parent doesn't provide it, the app will crash. So we accessing here, and if we are not going to use this, if there is no object with the same type then in the environment, then it's going to fail. When to use what? So here we have the summary of all the things we have learned and what is it best used for. Add state, local state inside a single view, we go with the add state. You want to modify the state owned by the parent view. So parent view has the add state, and this child view have add binding. That's how we are making the child view being able to modify the state of the parent view. Add observable object, actually observed object. Watch an observable object passed from parent, and state object owns and manages an observable object. So our counter model was the observable object, and the state object inside the view is owning that object which we created. When it comes to the environment object, it's a global shared state across multiple views. And just a final thought, if a view owns the state, use add state and add state object. But a child modifies the parent state, then based on what the parent is using, if it's using add state, we use add binding. If it's using add state object, we're going to use the add observed object. So if a view receives an object from a parent, we use add observed object. If a view needs shared global data, then we go with the add environment object. I try to dive deeper into the concept where we can manually refresh the view having the add state object so that we can see whether it's getting reinitialized or not, but practically it's not possible. And that is why we rely on our theoretical understanding, that is what at the runtimes actually happens, what SwiftUI is going to do, how the view is getting refreshed, reload, re-rendered, reinitialize, all are the same things. But recreation is different. That is what we were doing, and that is it. I hope you find this video informative, and I'll see you in the next one.